When the sun rises, birds take advantage to exit cover and use sunlight for flight. Hand-launched UAVs weigh less than 2 kilograms, and one operator can deploy them from cover in under a minute. Unmanned vehicles operate without onboard crew. Units include aerial drones for surveillance, ground vehicles for reconnaissance, and EOD. Some military UAVs fly over 24 hours straight using solar power and glide patterns to save battery, and naval drones for patrol. All systems rely on remote control or autonomous programming. Solar panels on the wings charge batteries during daylight. At altitude, the aircraft shuts off motors and enters glide mode. Glide uses airflow and lift to stay airborne without constant power. Result: longer patrol time with less fuel and fewer landings. Some glider UAVs use snap-fit airframes. Operator connects wing panels and tail boom by hand. Entire assembly takes under 2 minutes. Design prioritizes rapid field setup and minimal parts for logistics. Next-generation UAVs use onboard AI to fly in swarms for days using batteries, fuel cells, and solar power. While low observable designs and swappable payloads let one airframe handle recon, jamming, or supply missions. Research now focuses on fully autonomous dogfighting UAVs that coordinate attacks, evade missiles, and return to base without human control once given the mission objective. UGVs are used for reconnaissance, route clearance, casualty evacuation, and breaching operations to reduce human exposure in high-threat terrain. Next-gen UAVs are built around 3 core research key marks. Autonomy lets AI handle flight, navigation, target selection, and swarm coordination with minimal human input after the mission is assigned. Endurance comes from hybrid power systems using batteries, fuel cells, and solar arrays that keep the aircraft airborne for multi-day missions without landing. And modularity plus stealth means low observable airframes and swappable payloads let one platform reconfigure for reconnaissance, electronic warfare, or strike roles while reducing radar, thermal, and visual detection. As unmanned aerial systems evolve, they are redefining what's possible in the sky. Advances in materials, power, and intelligence are pushing aircraft to fly farther, adapt faster, and operate with greater independence than ever before. What began as remote-controlled tools are becoming collaborative partners in complex missions. The next generation of UAVs won't just follow commands. They'll anticipate, adjust, and extend human reach into environments once out of bounds. The age of autonomous flight is arriving, and it's changing the future of air power. The next generation of unmanned vehicles is advancing toward greater battlefield performance. While soldier personnel advance into the battlefield, high-risk zones remain dangerous and unpredictable for them. Limited visibility, unstable terrain, concealed enemy positions that restrict movement, and the constant pressure of time where any step forward can trigger an undetected threat. With UGVs, they deploy the vehicle to enter those zones first, using armored chassis, cameras, and sensors to map obstacles, detect anomalies, and transmit real-time data back to operators while absorbing hazards that would otherwise endanger human personnel. UGVs enter areas with mines, IEDs, chemical threats, or direct fire without exposing soldiers to injury or death. They can scout, clear, and hold dangerous positions while operators remain at a safe distance and retain control. Smaller UGVs are deployed for limited skirmish tasks because their size and profile reduce detection risk. They enter tight corridors, damage structures, and forward positions to conduct reconnaissance, mark targets, and disrupt enemy movement. They operate ahead of dismounted troops to test the area, then withdraw while relaying sensor data back to the team. In this scenario, soldiers remain low and observe as the mini UGV moves forward to deploy smoke and obscure the objective, creating concealment for a flank while the team maintains cover and monitors the vehicle's progress through sensors and optics. War evolved from trenches and fields where boots met mud, to planes that turned sky into strike lines and dropped bombs beyond sight, to ships and sea that stretched battle across horizons without a shoreline, to technology that now moves through all three at once, watching from above, rolling through dust and gliding beneath waves. So the front line is no longer a place, but a signal read before any flesh arrives. Technology is a blade with two edges. Dangerous because bombs, drones, and algorithms can reach farther than intent and miss more than they aim. Beneficial because those same sensors detect threats before a step is taken. Those same machines enter dangers so people don't. And those same networks turn chaos into coordinates. Let's now slip past the surface and read the deep. Introducing the next generation USV system. A compact unmanned surface vessel equipped with a robotic arm, advanced lighting systems, and a buoyant mini USV design engineered for stability and precision on open water. Designed for reconnaissance, environmental monitoring, search and rescue support, and data collection, this platform operates efficiently across various maritime conditions. Incredibly cost-effective, lightweight, and easy to deploy on the sea surface. The mini USV offers rapid deployment capabilities ideal for short-range missions and coastal operations. Alongside it, a larger boat drone system expands operational range and capability. Built for logistics delivery, reconnaissance, surveillance, and extended maritime support tasks, it bridges the gap between tactical mobility and heavy-duty functionality in a very next generation of fully autonomous, AI-integrated unmanned surface vehicle designed for multi-domain maritime dominance and intelligent ocean operations. Built with a modular adaptive hull system, it can reconfigure its structure depending on mission needs, ranging from high-speed reconnaissance to long-duration surveillance and deep water monitoring, powered by hybrid renewable energy systems, solar, wave harvesting, and high-efficiency electric propulsion. Introducing the next generation unmanned underwater vehicle, UUV, a fully autonomous and remotely operated deep sea system engineered for advanced underwater dominance and exploration. Its primary purpose is to operate in extreme marine environments where human access is limited or impossible, delivering precision capability for strategic underwater missions, including reconnaissance, target tracking, and specialized payload deployment. Designed for underwater missions and tactical operations, it can support high-risk objectives such as controlled detonation scenarios, hazard zone inspection, and critical infrastructure disruption or neutralization in secured environments. Powered by remote control systems and artificial intelligence, the UUV is capable of adaptive decision-making, real-time navigation, and intelligent path correction under unpredictable ocean conditions. UUV, USV, and all forms of unmanned vehicles represent the next unified evolution of autonomous systems across land, sea, and underwater domains. Together, these technologies redefine modern operations by shifting warfare, surveillance, logistics, and environmental missions from human-centered deployment to machine-driven precision. Their integration reduces direct human exposure to high-risk environments, increases operational efficiency, and enables continuous real-time intelligence gathering at scales previously impossible. In the future, warfare will become increasingly dominated by coordinated unmanned networks, where drones, surface vessels, Ground vehicles and underwater systems operate as a single, intelligent ecosystem. This will accelerate decision-making speed, expand battlefield reach, and enhance tactical accuracy. But it will also raise critical questions about control, accountability, and escalation in automated conflict. Ultimately, the rise of unmanned systems signals a major shift in the role of humans in conflict, from direct operators to strategic supervisors, relying on autonomous platforms to execute missions with precision, endurance, and minimal risk to human life. UAV systems further expand this unmanned network into the air domain, enabling high-altitude surveillance, precision strikes, and rapid reconnaissance across vast territories with unmatched mobility and speed. Their ability to operate in coordinated swarms with UUVs, USVs, and UGVs creates a fully integrated, multi-domain intelligence grid, where data is continuously shared and processed in real time. This new generation of UAVs strengthens the shift toward autonomous warfare, where decisions are increasingly supported or fully executed by AI-driven systems operating beyond traditional human limitations.